Our today's chapter is electrostatics. Electrostatics is a branch of physics which deals with electric charge at rest. Electric charge is a fundamental quantity. Electric charge is a fundamental quantity, which means that electric charge cannot be breaked upon or further divided at microscopic level, and hence becomes the basic in electrostatics. The same electric charge will be used in our further discussion. Consider this atom. Atom consists of centrally located nucleus. Inside this nucleus there are protons, there are neutrons, and surrounding to this are the electrons. Now protons are positively charged, neutrons do not carry any charge, and electrons have negative charge. Normally, number of protons is equal to number of electrons. So what happens? Body is electrically neutral. Now suppose if I add electron to this, so what will happen? Add electrons. So number of proton will be less than number of electrons. So body will have a negative charge. Now suppose in case I remove electrons, then number of protons will be more than number of electrons. So the body will have a positive charge. Properties of electric charge. The first property is conservation of electric charge. Second, quantization of charge. Third, nature of force between the charge. Fourth, obey inverse coil law. Fifth, electric charge are additive. Sixth, charge is always associated with mass. Seventh, charged body always attract an uncharged body. So we'll see the first one, that is conservation of charge. So what this property says is that the sum total charge of an isolated system is constant. Okay, that is, the charge can neither be created nor it can be destroyed in an isolated system, and this is called the principle of conservation of charge. Now we'll learn this with an example. Let us consider a system in which this is my system. I have one glass rod, okay, and I have one silk cloth. Okay, this is my system. The net charge of this system is 0. Now what I am going to do, I am going to rub the silk cloth on the glass rod. So what will happen? There will be transfer of electrons. Okay, now after the transfer of electrons, the glass rod will lose electrons to silk. Now let us consider glass rod has lost 5 electrons and silk cloth has gained 5 electrons. Okay, so because of which the glass rod will attain a positive charge and the silk cloth will have a negative charge. But now if we consider this system, what is the total net charge of the system? Total net charge is plus 5e minus 5e is equal to 0. So net charge is also 0. The net charge of this system was 0 before rubbing, and after it was rubbed also the net charge of the system is 0. So this is conservation of electric charge. Our next property is quantization of charge. This property says is that any charged body, large or small, has a total charge q, which is the integral multiple of plus or minus 1e, plus or minus 2e, plus or minus 3e. This is known as quantization of charge. Okay, now we'll understand this. Suppose if I have body A and body B, both bodies are neutral. Now what I do, I rub these two bodies. So what will happen? There will be transfer of electrons. Now consider there is transfer of 3 electrons. 3 electrons transfer from body A to body B. So what will happen? Body A will have positive charge and body B will have a negative charge. So charge on body A will be given as plus 3e and charge on body B will be given as minus 3. So from this we should know that charge on any body is always an integral multiple. For example, charge on any body can be plus or minus 1e, plus or minus 2e, plus or minus 3e, till plus or minus any. It can have any of these values. Okay, it cannot be a fraction. A charge cannot be a fraction. This is wrong. A charge cannot be a fraction. It should be always an integral multiplus. So this brings us to the equation, that is q is equal to ne. Sorry. So this brings us to the equation q is equal to plus or minus ne, where q is the total charge, okay, n is number of electrons, and E is value of one charge of electron. So what is the value of one charge of electron? 1.6 into 10 raised to minus 19 coulomb. Okay, so the third property is nature of force between charge. So there are basically two types of charges: positive charge and negative charge. Okay, positive and negative. The positive charge and positive charge, if placed close to each other, they will start repelling each other. Okay, a force will be experienced by both the charge to move away from each other. So basically this is like magnet. Okay, so north pole and north pole will repel each other, south pole and south pole will attract each other. So these are like poles repel each other. Similarly, the case if I place negative charge close to each other, they will repel each other. What if I place positive charge close to a negative charge? The behavior will be they will attract each other. Okay, they will attract each other. So unlike charges, attract each other. So with this we'll move on to our next property. Our next property is electric charge obeys inverse square law, which means that if I place a positive charge over here and one more negative charge, let us say the distance between them is r. Okay, the first thing what I am going to do is increase r. So what will happen as I move this away, as I move this charge away from this positive charge, the force of attraction between them will decrease. And if I decrease r, that means I get this close together, okay, decrease r, what will happen? Force of attraction between them will increase. So basically force of attraction between two charges is given by 1.4 pi epsilon naught q1 q2 upon r square. So now this r plays a major role over here. As you will increase r, force will decrease, and as the r is decreased, the force will increase. Next property is electric charge additive, which means that from this word only, that additive, that electric charges can be added. Now we'll understand this. Let us consider this body. Okay, I will name this as A. There are other bodies surrounding to this, B, C and D. First what I do, I rub these two bodies A and B, and what happens is that B loses electrons and gains positive charge of 3e. So A will have a negative charge, okay, since B has lost electron to A. Now I rub these two bodies A and C. So what happens? A loses its 2 electrons and gains a positive charge, whereas C gains a negative charge. Similarly, I rub these two bodies A and D. So this transfer of electrons from A to D, and let's say A gains positive charge of 5 and D gains of -5. So now if I say what is total charge on A, total charge on A, so it should be given by -3e plus 2e plus 5e. So 5 plus 2 7, 7 minus 3 is 4, sign is positive. So the total charge is 4e. This is the property that electric charges are additive. So we'll go on to the next property. Charge is always associated with mass. Okay, electric charge will always carry mass. Now as we know that charge is equal to Q is equal to N into E. Okay, now E is electron or charge on one electron, so all electron has mass, so definitely the total charge will also have mass. Okay, so this property is electric charge is always associated with mass, that is charge cannot exist without mass, though mass can exist without charge. So with this we will move on to the next property, that is a charged body always attract an uncharged body. Now let us consider I have two bodies, body A and this is body B. B is uncharged, it is neutral, it does not carry any charge, whereas A has a positive charge on its surface. Now suppose if I get these two bodies close to each other, what will happen? Because of induction there will be a negative charge developed on this side of B. Okay, so the other side of B will form a positive charge. So whenever an uncharged body is brought near a charged body, okay, as shown, the electrostatic induction takes place. As a result, the net force is attractive. Okay, so because of this positive and negative, as we know that unlike charges attract each other, this will attract each other. These two bodies will attract each other. Similarly, if I have a negative body, a body with a negative charge is brought in contact with a body which is neutral. So what will happen? Because of induction, a positive charge will be developed on this side of the body, and negative side on the other, negative charge on the other side. So these two bodies will attract each other. Okay, with this I'll move on to a next property, which I did not mention over here. That is two identical bodies A and B. Okay, there are two identical bodies A and B, and they have charge of Q1 and Q2. Okay, when they touch each other, what will happen? Suppose there are two bodies having charge Q1 and Q2. If they are made to touch each other and then they are separated, okay, then they are separated. So what will happen? The charge on these bodies will be Q1 plus Q2 upon 2. Similarly, charge on this body will be Q1 plus Q2 upon 2. So they are basically made to touch and separate. So new charge will be Q1 plus Q2 upon 2. One more thing I'd like to add over here is the unit of charge. What is unit of charge? Unit of charge is coulomb. Okay, this is SI unit of charge, and what is CGS unit of charge is stat coulomb. So we have finished with the properties of electric charge.